The Chapter 7 skills review mostly relates to working with fractions, and specifically that's multiplying and dividing fractions, and also simplifying fractions. So one of the skills we need to simplify fractions is to be able to list the factors of a number so that we can compare it to the factors of another number. So our first task is to just list all the factors of the number 36, the example given below. So one nice way to do this is to list them in pairs. We know a factor is a number that is a whole number which times another whole number is equal to the given number. So 1 and 36, 1 times 36 is 36. Those are two whole numbers whose product is 36. Then we can continue. 2 times 18 and 3 times 12 and 4 times 9. 5 is not a factor of 36. There's no whole number that is 5 times that number is equal to 36, but 6 works, times 6. And this is the point where we can stop. Once these numbers are either equal to each other, or if the next pair was going to be larger, we'd realize that we would write 9 and 4, and we'd begin to repeat the factors that we already have up above. So as soon as the first number might be larger than the second, you're probably done. And maybe not. If not, you might have just missed a pair previously. So to write the full list, we have 1, 2, 3, 4, and so forth. We'll just write it in order just to organize the work we've done. Of course, we won't do many problems like this. It's just a basic skill to find common factors between two numbers so that we can simplify a fraction. Okay, so to practice one more, and again, since we're just using this to simplify fractions, knowing all the factors of a number, that can be a difficult thing to do. So maybe we don't need to know all the factors of a number. In many cases, we're just looking for common factors among two different numbers. But just for one more round of practice with this method, let's list all the factors of 200. So we have 1 and 200. We have 2. Now the way to think about it is 2 divides 200, and that gives us 100. In other words, 2 times 100 is 200. 3 does not. We have 4, and 4 times 50 is 200. We could just divide 200 by 4 to find that 50. We know that 5 divides 200, and that's 40. So 5 times 40 is 200. Writing out these pairs as usual. 6 will not divide 200. 7 will not. 8 does. 8 is 25 is the value here. We can divide 200 by 8 to get 25 if we needed that. For these later ones, that might be necessary. 9 does not divide 200. 10 does. And then we have numbers like 11, 12, 13, and 14 that are not factors of 200. 15 is not. 16 does not. 17, 18, and 19 do not. And then we would finally arrive at 20 again, but that would match our pair with 10. So that's redundant. We don't need to add that to the list. So that's all the pairs of factors of 200. And we can list them again in one long list in order by going down each of the columns. Oops. And then up the right column. Either list is fine. And again, it's not so much about factoring these numbers as it is finding factors of these numbers that might be common to another number. That's what the point of these exercises really are. But there are a few questions that have you do this. So you should be prepared to be able to do that. So to get to some of the main points is simplifying fractions. So this is our first operation with a fraction, is to recognize when two fractions have a common factor. So, when the two parts of a fraction, the numerator, the top, and the denominator, the bottom, have a common factor in them. In this case, we recognize that 3 has the factors 3 times 1, and 9 has the factors 3 times 3. So any common factors from a number in a numerator to a number in a denominator, in this case, 3 and 3, can cancel. They'll divide each other out, and that becomes 1 and 1 right here. So we have 1 times 1 in the numerator over 1 times 3 in the denominator. Being very slow about this, the student might not want to use all these steps every time, but I'll add the additional steps as we go. So we've done another sort of extra step in here. We've also done some fraction multiplication. So in other words, we had a 1 times a 1 here, which gave us this 1. And then we had a 1 times a 3 after our cancellation, which of course gave us this term in the denominator. And overall, we were 1/3. In many cases, I think students will be comfortable just scratching each of these out and saying it's 1/3 in the next line. And that's fine as well, but the extra steps could help some. And if you're not sure about something, maybe the extra steps might help you. So let's simplify the fraction 6 over 14. And we'll recognize that 6 has 2 times 3 as a factor, as 2 factors of it. And 14 factors is 2 times 7. And we chose 2 because we saw that both of those numbers were even. So we knew that both would have a factor of 2. And that would leave us, once those 2 factors cancel, with 3/7. 3 and 7 have no factors in common other than 1, so it won't simplify any further. So that's simplifying fractions. Now let's move on to multiplying and dividing fractions, decimals, and or whole numbers. So our first task is 0.3 times negative 0.6. We'll have a positive times a negative. So I know my answer will be negative. I know that 3 times 6 is 18. And I have 2 decimal places, 1 and 2, involved in this calculation. So I'll have to move my decimal place 1, 2 to the left when I'm done. So our final answer here is negative 0.18. Another way students might have seen this done in the past is to take 0.3 times 0.6. And I'll leave the negative off for now, but we'll know that our answer should be negative. Maybe I'll put that reminder down here. And we do 6 times 3, and that's 18. And then when we're done with this, we move the decimal place 2 places for each of these 2 decimals to count all of them up. So that leaves us with 0.18, just as we got before. And of course, the negative sign is there because we multiplied a positive number times a negative number. So that takes care of that. Also, calculators are always available in this class. So decimal products like that can be handled with your calculator as well. Now let's see, calculate the product of negative 24 times 1/8. So this is a whole number, negative 24 times a fraction, 1/8. So maybe one way we want to do this is leave the negative sign out front and write 24 as 24 over 1 times 1 over 8. And that way we've converted our whole number to a fraction. And remember that any number, any whole number is itself divided by 1. 24 divided by 1 is still 24. So we can express it as a fraction. The reason we do that is because multiplication with fractions is numerator times numerator over denominator times denominator. So that's top times top divided by bottom times bottom. So negative, it's 24 times 1 over 1 times 8. So we end up with negative 24 over 8. Now again, all these steps may not be necessary for some, so don't worry about writing them down if you don't need them. But when we arrive at negative 24 over 8, we realize that 24 factors as 8 and 3. And that's divided by 8. So these common factors of 8 cancel a value of 1. We end up with negative 3. The other way a student might have seen this is to quickly just look and say, this is negative 24 times 1/8. So it's negative 24 divided by 8. We did that product nice and quickly, and that's how we arrive at negative 3. If you didn't see that, that's fine. The steps are there to help you with that. So continuing to calculate products and quotients. So to multiply and divide, we've got 3/4 times 1/8 as our next problem. And as we said before, it's 3 times 1 divided by 4 times 8. And that's 3 over 4 times 8 is 32. 3 and 32 have no common factors. So we're done here. This is a simplified answer. It's best to simplify your answer, particularly in the online homework. You should check to make sure that you're putting your answer in the form they ask for. If they want a decimal rounded to certain places, then do that. If they want a simplified fraction, then of course simplify the fraction and input that. This would be a correct simplified fraction for this problem. Now calculate the product of this mixed number. So it's a whole number with a fraction or mixed fraction times this proper fraction. This is a fraction with a numerator that's smaller than the denominator. We have a positive times a negative. So again, we're going to get a negative answer overall. So if we had a negative times a negative, we'd have a positive answer overall, just for some insight there. But the first thing we need to do is we need to convert 1 over 7/8, or 1 and 7/8 to an improper fraction, or at least not a mixed fraction anymore. In order to do that, we take 8 times 1 and then add that to 7. So that will give us 8 times 1 plus 7, and then we put it all over 8. So it's the denominator times the whole number, this part, plus the numerator, all divided by the denominator. Okay, so a little bit of practice and that should come back to you pretty quickly. But 8 times 1 is 8, plus 7 is 15 over 8. Now we have out front, that minus sign's been moved over there just to keep it out of our way. We have 15 over 8 times 5 over 16. And now we're back at normal fraction multiplication. So we'll multiply the numerator times the numerator and the denominator times the denominator. So we have 15 times 5, calculator might be handy here, over 8 times 16. And we have, in this case, negative 75 here, and then 128 for the bottom one. Calculator can help with the steps. And also remember, a calculator can do this thing overall too. Especially the TI-30 and the Casio 300, which are the course required calculators. So now we calculate the quotient, or we calculate a division of two fractions. So there's a nice little saying for division of two fractions, and that's keep, change, flip. Okay, so what does that mean? So in other words, it tells us to keep the first fraction the same, change the division to a times, and flip the second fraction. That will effectively be our division of 3/4 by 2/5. Okay, to multiply 3/4 by 5/2. Okay, that is the nice rule on that. Keep, change, flip from left to right in a division scenario. So we have 3/4, or 3 times 5 over 4 times 2, numerator times numerator over denominator times denominator. This is 15 over 8. And 15 over 8 is an improper fraction because the numerator is larger than the denominator. So if it was okay to express your answer as an improper fraction, that's fine. However, many cases they'll ask for a mixed fraction if you have an improper fraction. So in order to get a mixed fraction from this, so in case we need that, we can write 15 over 8, and we can figure out how many times 8 goes into 15. You can write that as, well, there's only one time that 8 goes into 15, and there's 7 left over. So 8 and 7 is 15. So we know that much. And it's all divided by 8 still. I'm just changing this number up top to be expressed like this. Now we can split the sum in the numerator of a fraction to be 8 times 1 over 8 plus 7 over 8. Okay, we'll do sums of fractions later, but this is a basic rule. We can split the sum in the numerator of a fraction to have two different fractions. And 8 over 8 is 1 plus 7/8 gives us 1 and 7/8. So that's the mixed fraction, or mixed number, they might call it sometimes. It's got a whole number and a proper fraction. So that's the idea there. Okay, and one last quotient to calculate. We have 3/4 divided by 2. Remember, we're going to keep 3/4, the first fraction, change the division to times, and flip 2 to be 1/2. Why would we flip 2 to be 1/2? Remember that 2 is actually equal to 2 over 1. So when we flip 2, its flip puts it as 1 over 2. So that's the secret here. Dividing a fraction by a whole number, 3/4 divided by 2, we're at 3/4 times 1/2. Now this is equal to 3 times 1 over 4 times 2, and that's 3/8. This one won't simplify any further, and it's a proper fraction, so we're all done. Our last topic in the Chapter 7 skills problems is exponential notation. So if we have factors of numbers and we have common factors, in other words, we have 5 copies of 6s right here, and we have 3 factors of 2 in this expression, we can write this in terms of powers of 6 and 2. Now what the question is asking is, express this product, this multiplication, in terms of powers of 6 and 2. It's not saying tell us what the answer is or what the value is. Don't calculate it, just rewrite it. So since we have 6 times 6 times 6 times itself 5 times, its exponent is 5. So you can just write 6 to the 5th. So this term is equal to all 5 of these 6's times each other. Okay, and similarly, 2 cubed, or 2 to the 3rd. There are 3 2's, so we write 2 with an exponent of 3, and we've been able to simplify the notation from this side over to a more compact way to write this on the right. Now, it's not quite clear why we would want to do that in these examples, but within the real material, in the actual Math 120 material of Chapter 7, we're going to need to use exponential notation quite a bit. Now we've got, in this case, 3 4's, so we'll have 4 cubed, 4 to the power of 3 to match the 3 4's, factors of 4 that we have there. Next, we have -6 times -6. So be careful with this, since it does have a minus sign. Put parentheses around -6. That's the full thing that we have multiple copies of. There are 2 factors of -6, or 2 multiples of -6. So we have an exponent of 2. But what we might realize is that if we have a negative number squared, we just have to remember that -1 squared is -1 times itself, and a negative number squared is a positive number. And this comes out to be positive. So we can cancel the minus sign for this -6 or any negative number inside here if this exponent is an even number. If it's an odd number, we have to keep it. So that's it for Chapter 7. Finding factors of numbers, simplifying fractions, multiplying and dividing fractions, and this basic exponential notation that we have here.